Dear viewers, I welcome you to the second class of heat exchangers. First, let us have some summary of class 1 within couple of sentences. We got to know that any device that exchanges heat is called as heat exchanger, and it was classified into two categories: parallel flow and counter flow, based on direction of flow. In case of parallel flow, both hot and cold fluid were moving in same direction. Similarly, counter flow, here the direction of hot fluid and the cold fluid was something like opposite in nature. So I can say that is opposite direction. Now these two, if you try to analyze it, we came to this classification. We summarize this classification based on the direction of flow of a fluid. Based on this flow direction, we have these two categories. Now it may be same or opposite. In the other point of view, we can also classify that one as crossed flow heat exchanger. This is the third category based on direction of flow. Now under this cross flow heat exchangers, it is again classified into two subclassification. One is, these two are for this third point. These cross flow heat exchangers are classified into two different categories. One is unmixed flow, and then second one is mixed flow. That means if we have number of tubes through which hot fluid is flowing, now I can pass the cold fluid in the direction perpendicular to this direction of hot fluid. So this will be cold fluid, and this flow direction is exactly perpendicular to that hot fluid direction. Now why is it called as unmixed? In a sense, this direction, it has one particular path to follow, whereas in mixed we don't follow anything like particular direction. It may flow in any of the direction. Likewise, it is something like mixed. So to understand this better, we can speak about examples. So what are the examples for these heat exchangers? In a sense, first one we can list under automobile field as radiator. The radiator part, which is used to cool the engine, is an example for heat exchanger, and it belongs to this particular kind unmixed, where we have number of tubes through which hot water will be flowing, and we'll be having number of fins through which air is flowing. So this direction of air is controlled by the direction of fins. The way we position the fins controls the direction of this cold fluid. So radiator is one of the example for heat exchanger, and in particular it comes under cross flow, and again under cross flow we can categorize this radiator for unmixed category. So now when we speak about boilers, we have many more examples for heat exchangers, such as air preheater, we have superheater, that is a device called as economizer. Under refrigeration we have condenser, we have evaporator, and we have many more. Now here when we speak about condenser and evaporator, this comes under mixed flow, because the condenser is that part which is at the rear end of the refrigerator. Under rear end there is a flow of air. We cannot control the direction of flow of air as we are doing it here, but here it's a natural air that is being flown. I cannot expect that air to move in particular direction. So this condenser is an best example for mixed type of crossed flow heat exchanger. Fine. So now this, you should be aware of the meaning of these words. If I say air preheater, air which is going to the combustion chamber in an boiler, it will be heated up before entering into the chamber by means of exhaust gases. Superheater, that is a device which converts the steam to superheated steam. And economizer, this is a device which heats the water before it enters into the boiler. So these three are the devices of boiler. This is an example from automobiles, and these two are the examples from refrigerators, and these two are something like special cases. Now why is this called a special case in a sense? I'll explain it here. So before coming to condenser, you need to recall parallel flow heat exchanger. Here the direction was same for hot and cold fluid, and this is the temperature variation across the length, right? Now what is that condenser? It is that device which exchanges heat between the hot fluid and the cold fluid, where hot fluid gets condensed. That means there is a change of phase in hot fluid. Whenever we say about phase change, remember that there is no change in temperature, so this temperature remains constant. That is how phase change is achieved, right? So now apply the same knowledge over here. This is the hot fluid. Now its temperature should not change, but with the help of latent heat, it takes the latent heat, fine, sorry, it gives the latent heat to the cold fluid, and it gets converted its phase from gas to liquid. That means we can summarize it like having a straight line. This is the hot fluid inlet, and this is hot fluid outlet. We are taking example of parallel flow, fine. So the cold fluid graph remains same, cold fluid inlet, and this is cold fluid outlet. And the temperature difference at the inlet end, this is called as theta1, and here the temperature difference is called as theta2. This is what the temperature variation in condenser. Why is it like straight line in the sense? Because here there is a phase change of a refrigerant which changes its phase from gaseous to liquid. From gaseous refrigerant it gets converted into liquid refrigerant. Again it goes back to the evaporator. In the evaporator, it absorbs the heat. It doesn't give the heat, it will absorb the heat. That means phase will be changed from the liquid to gas again. So that will be considered as cold fluid. So now the cold fluid temperature remains same. This is what cold fluid temperature at inlet and cold fluid temperature at outlet. And now compare it to the parallel flow. The hot fluid curve remains same. Hot fluid inlet and hot fluid outlet. Here I have taken parallel flow as an example. It's not a necessary condition. You can also imagine the same kind of diagrams with the help of counter flow heat exchanger. The thing is, in case of condenser, remember to make a straight line for hot fluid, and in case of evaporator, the cold fluid line should be straight. Why is it straight again here? Because of phase change, where there is no change in temperature, fine. And here liquid refrigerant gets converted into gaseous form, and hence these two are taken as special cases. In other things, there is nothing like phase change. It is just a heat exchange where we'll be speaking about specific heat. But these are the two cases where we'll be speaking about latent heat. Latent heat. This is the heat which is corresponding to the phase change of any system. So now this is the summary. These are the things you need to remember. Whatever it is there in black, it is from class 1. continuation part is there in blue. So along with heat exchangers, two different heat exchangers, we have added one more. It is broadly classified into two sub-classification, unmixed and mixed. Here are the examples. Try to have a revision of this thing. Thank you.